we are going to deal with the chapter which is force and pressure. So at first, the first thing which comes is, what is force? Force, we can define force as any pull or push. Like force, any pull or push. So whenever anything is pushed or pulled, we apply force, right? That is the for the basic definition of force. So under force there are many things comes, which is like, if the force which we apply is in the same direction, like two forces are applied in the same direction, like I'm applying one force and another force in the same direction, there is an object, I'm applying force F1, just the name of the force is F1, the second name, let's name it F2. If we apply both the force on this object, then the total force will add up, that is force 1 and force 2 will add up, and it will give, means the total object which will, the total force which will apply on this object will be F1 plus F2. It is a total force, right? So again, if the force applied on the object is from different directions, suppose this is the object and one force F1, it is being applied from this direction, and another force F2, it is applied from this direction. So what do you think? From in which direction the object will move, right? So to find this, what we will do is we will subtract that force one, this force and this one. Both the force will be subtracted, like F2 minus F1 equals to whatever we get will be the total force. And if the force applied F2 is greater than F1, like F2 is greater than F1, if this force is greater, then this object will move this side. And if F1 is greater, then the object will move this side. It's common sense, right? So in this case, if the force applied is from different directions, then both the force will subtract. And if the force applied is on the same direction, then both the force will add up, right? So next thing, what comes is some of the properties of force. What force can do? Force can, number one, force can change the state of an object. Suppose this is the marker cap and force. I'm applying moving. From rest, it starts to move to motion. So it is a changing its state of motion. And force can change the state of motion of an object. So a force can change an object from rest to motion. And again, it can also change an object which is in motion to again rest. We can change an object, like a ball is moving. We can stop it by applying force. Again, if you kick the ball, like a ball is in rest, if we kick, it again starts to move. Like here we are changing the state, like from rest to motion we are changing by applying force. Again, from motion to rest we are changing its motion, state of motion by applying force. So what can force do? Force can change the state of motion of an object. What else force can do? Number two, force can change the shape of an object, right? By applying force, we can change the shape of any object. We can suppose, let's see, I have a paper. So this much big, right? I'm applying force, I'm squeezing it, its shape changed, right? Circular. Then again, I apply force, it becomes a bit bigger. We are changing its shape, right? Right? And we have no doubt that atta, when we are making chapati, we apply force to make different shapes of it. So what can do force? Force can change the shape of an object. Another thing which force can do, what? Force can change the speed of an object, right? The most common example, when we all ride bicycles, cars or scooters, what does the accelerator do? When you apply more accelerator, its speeds increases, right? Accelerator means applying force. More force is being applied by the engine to the wheels. So by applying the force, more force, we can go more, we can achieve more speed. Means force can change the speed of an object. And again, by applying brakes, brakes also type of force. Yeah, it's a force, frictional force, which we will discuss later in the coming in the coming chapter. Force can also increase the speed as well as decrease the speed of an object. And force can change the speed of an object. It can increase its speed, it can decrease its speed also. So now what comes? There are two types of forces, which is, for the first force is contact force. What is contact force? When the force applied by an object to the object are touching each other. For example, as I'm moving this copy like this, right? Like this. So my hand, I'm applying the force with my hand, and this copy is moving in the direction. So here my hand and the copy is are being touched, right? So this is called contact force. When the object and the force applied touches each other, then it is called contact force. And under contact force, two types of force comes. That is muscular force and frictional force. What is muscular force? Whatsoever the force we apply with our muscles, it is muscular force. And what is frictional force? We'll come to know in the next chapter in more details. But for now, we can understand frictional force is like the roughness between objects, like my hand and this hand. I'm rubbing each other, and there are some force between the hands which is opposing the direction. The force is opposite the direction is called frictional force. We'll come in details in the next chapter, which is friction. So, how can we define muscular force? The force applied with our muscles, from our muscles, is muscular force. So let's write it. Force applied by muscles is muscular force. Then frictional force is the opposing force between the objects. We'll be coming in details in the next chapter about this. Just for now, we can say that frictional force is the opposing force. Like if I tell you, whenever we do something, there is some opposing force, right? Like I'm rubbing my hand over this whiteboard, and there is some force applied by the whiteboard, which is like I cannot move my hand smoothly, right? Because there is some force which is opposing my direction in my hand in the direction, right? And the opposing force is the frictional force. I will be telling you details in the next chapter. So the first thing which we learn is contact force, and another force which comes is the non-contact force. So what is non-contact force? Very easy. The opposite of contact force is non-contact force. In contact force, we said that the objects touches each other, but in non-contact force, the objects don't touch each other. they show their influence without touching each other. So can you think what non-contact force? What are the non-contact forces? Examples like first one is we can say gravitational force. The force of gravity, gravitational force. Earth is pulling us down, right? See, this marker cam is here, but as soon as I release it, it goes down, right? So why it goes down? Because Earth is pulling it down. The force is exerted by the Earth, right? But here, is there a contact between the Earth and this gap? No contact, but still it's going down. This is non-contact force. The force without any contact, right? So the first non-contact force is gravitational force. Second is magnetic force. I guess everyone has seen the magnet bars, right? Even we have studied the chapter magnetism, I guess. So between two magnets, suppose there is a magnet and one magnet, they both pull or repel each other, right? Depending on the situations. So this force is also a type of non-contact force, where two objects are being pulled with the power of magnet. That is magnetism. The third non-contact force is, what is that? That is electrostatic force. Like electrostatic force. Electrostatic force is also a type of magnetic force, where the force is created due to electricity. Okay, like there are some some magnets also which is being operated with the help of electricity, right? So just the thing is, you don't need to go for the definitions much. It's like non-contact force. Under non-contact force, there comes gravitational force, magnetic force, and electrostatic force. Done. So, and then what comes is the second part of the chapter, pressure. It's very interesting. So, how will we define pressure? Let's write it. Pressure. Pressure. See this marker? I'm applying a pressure on the board. So, how can we define pressure? There is no definition of pressure, exact definition, but it is a mathematical formula, which means pressure equals to force by area. It means that when I apply a force on any object, right? Suppose I am applying a force like this here. I am applying a force of suppose whatsoever on an object, and if the force is applied on a particular area, suppose let's take this is object, a surface. A force is applied right here, okay, and suppose this is the area of suppose 10 centimeters square, a square, right? Let's a square area. Force is applied on this square part of the surface. So, how much force is applied on this area is known as pressure. Whatever the force we apply on a particular area, that is called pressure. Is it clear? It's very simple. Just remember that force pressure equals to force applied by area. Another relation, the very interesting relation between pressure, force and area is that these are the proportionality constant. Whenever the area will increase, pressure will decrease, and whenever the force will increase, pressure will also increase. Confusing, right? Black and white. Pressure area decreases. Area increases, pressure decreases. Pressure increases, force increases. Force increases, again pressure will increase, right? So what is this? If pressure increase, area will decrease. If area increase, pressure will decrease. How it's happening is like, it's very simple. See, it's like, let me write here. You see, P equals to F by A. So they are like this, upper niche, upside and downside. So that's the thing is, remember, in this way, this will increase, this will increase. If this increase, this will decrease. If this increase, this will decrease. And P and F, which are both at upside. So this one, if this increase, this will also increase. But this one, this is up down. If up down, increase decrease, decrease increase, increase decrease, right? It's very simple. But how it's happening is, we can do an experiment also. See, I have a glass, right? I have a glass. So if I put this glass like this on my hand, right? I'm experiencing some pressure on my hand, right? And I'm again putting this glass like this. Even you all can do and see in which case you're having more pressure, you're feeling more pain or more pressure. It will be like this. You know why? Because like this, what's happening? This area of contact is less, right? If area of contact is less, what I said, if area is less, pressure is more, right? And if like this, the area increases, right? The area of this contact, the area of contact increases. So area increase. So what? If area increase, pressure will decrease, means less pain, right? You can try at your home also this one. So what can we learn from here is the unit of pressure. How can we measure the pressure? It's very easy. Pressure equals to force by area. So what is the unit of force? The unit of force is Newton. And what is the unit of area? We have all learned unit of area in square. Whenever we find the area of the square or rectangle or anything, what you write? Centimeter square or meter square, something like that, right? So unit of area is meter square. So the unit of pressure will be Newton per meter square, right? Which can also be written as Pascal, which is denoted as PS, right? Simple. And pressure exert, this is the pressure. So is the pressure exerted by only our hand or any muscular force? No, but pressure is also being exerted by gases and liquids. So pressure exerted by gas and liquids. Again, let me take this glass. So if we fill this glass with some water, then the water will exert pressure on the glass in equal amount in all the direction. In this direction also, this direction, all direction, the liquid will exert the pressure on the surface of the glass. And this pressure increase with height. If the water is more, like if the water is till this much, then the pressure will be less. If the water is this much, then pressure will be more. So more the liquid, more the height of the liquid in the container, more is the pressure. It's the same in case of gas. Gas also exerts pressure over the container, over the wall of the container in the same way as the liquids. So another thing, the last topic which comes is at atmospheric pressure. So how can you define atmospheric pressure? Pressure exerted by the atmosphere on the Earth's surface is called atmospheric pressure, right? So the pressure exerted by the Earth's atmosphere on the Earth is the atmospheric pressure. Like our Earth is surrounded by gases, by different types of gases, which is constantly exerting pressure on the Earth's surface. And this pressure is known as atmospheric pressure. And there's a very interesting fact that atmospheric pressure is very high. If you see just atmospheric pressure for column of this much of 10 centimeter, 10 centimeter and 10 centimeter, then it's coming something like 1000 kg of atmospheric pressure. So the obvious question may come that if the atmospheric pressure is so high, then why are we not being crushed by the atmosphere? It is because of the fact which we have learned in the beginning of the chapter, that is, the force applied means the force applied from the two different opposite directions. Suppose this is the atmospheric pressure and this is the pressure of our body. Okay, in this case, the pressure exerted by our body, the pressure exerted by the atmosphere is same. So what that does is they cancel out each other. That's why we don't feel that atmospheric pressure at all. Right? So this much only in this chapter.